A very good morning and welcome to this module, a self-learning module on emergency structural response. My name is Arun Menon and I'm a professor of structural engineering at IIT Madras in Chennai. My focus is going to be on the necessary aspects related to emergency response focused on a building, focused on the structure. Historical monuments and heritage structures typically represent an augmented vulnerability to natural and human-made hazards due to a series of reasons. Often, regions over time experience an increased frequency of hazards, or there could be scenarios where a region which never experienced a certain type of hazard is now experiencing the new hazard. This could be one scenario. The other aspect with historical constructions is, given their lifespan, over time, there is a continuous aging and weathering of structural materials. And this leads to a weakening of the structure and reduced capacity over time. In few cases, it could also happen that the original structure does not have structural features to resist a certain type of hazard. These factors can lead to an augmented vulnerability of historical monuments and heritage structures to natural and human-made hazards. And several instances in the past, in the subcontinent, have shown such augmented vulnerability in historical constructions. Given the lifespan of historical monuments, it is quite clear that these monuments would have experienced such natural calamities time and again over its lifespan. And this, if you take the case of earthquakes, is quite evident in several of the regions in the subcontinent, like Bhuj in Gujarat, where large earthquakes occur once in 180 to 200 years. In the Nepal Kathmandu Valley, about 80 years interval, you have massive earthquakes. And in Bagan, about 40 to 50 years, there are massive earthquakes, devastating earthquakes that can occur. Now, one has to understand that in a region where multiple small earthquakes occur rather frequently, the local construction practice and the local community is quite aware and has the earthquake problem present in its mind and memory. However, there are regions where massive earthquakes occur, but they're not very frequent. They occur probably once in 100 years or more. And the smaller earthquakes are almost infrequent. They don't happen at all, which means the population is not exposed to the earthquake hazard or any other disaster for that matter on a regular basis. It is absent from the human memory. And therefore, the local construction practice and the local community's response is absent in the event of the occurrence of such a natural disaster. In case there is a local culture to construct earthquake-resistant or disaster-resistant constructions, this is referred to as local seismic cultures, but it is very much dependent on the frequency of the large earthquakes versus the frequency of the low to moderate earthquakes. Low to moderate earthquakes are reminders. The large earthquakes can be devastating, but rather infrequent. So this is something one needs to keep in mind. And there are several regions in the world which can be categorized into this in this characteristic. It's very important that therefore we realize that when we interact with historical monuments, we are actually interacting with these monuments or intervening in these monuments between two natural calamities to repair them or to assess them or to ensure that they are safe for the next event. And in Sir Bernard Fielding's words, it's very clear, this message is very clear, that lessons must be learned continually, and we must always be aware that we live between two earthquakes as far as the historical monument is concerned. It could be any two natural disasters. As I said, historical monuments and all constructions for that matter are exposed to multiple hazards. We must be aware that a region receives a certain amount of precipitation, Sometimes it may be above average. Certain regions which were hitherto dry areas are today experiencing extremely high precipitation levels, which may lead to soil erosion, which may lead to situations in monuments which earlier was not expected. So rainfall and floods could be another hazard that we must be prepared to ensure safety of these constructions. Fire hazards, again, are quite common in historical constructions because of multiple reasons. These constructions have a lot of timber very often. You have flammable material in them. You could have wiring which is faulty, which is not upgraded. That could trigger fires. But you could also have structures which are religious structures and use a lot of open fires in lamps, and they could trigger fires as well. So fire hazards are again common in historical constructions and to be considered as one of the hazards against which we have to be careful about. Those constructions which are present on slopes, slope stability can be a concern, and slope stability typically becomes problematic in the presence of other natural scenarios like rainfalls and earthquakes. So slope stability can be a concern. They could be failures could be triggered by rainfall, failures could be triggered by earthquakes, and therefore in hilly regions like these examples that you see here, it's quite important that the stability of the slope is assessed, and that has a direct impact on the structures which are situated on these slopes. We've talked about natural disasters. Of course, fire is, again, you can't consider that as a natural disaster unless it's a forest fire. But in cases of buildings, it could be due to negligence, or it could be due to human-made factors that the fire disaster occurs. However, if you consider infrastructure development in the vicinity of historical constructions and heritage buildings, this could become a problem for the safety of these constructions. Today, in most old cities across the world, metro constructions are becoming a reality, and the old cities typically are highly congested regions, and therefore you will have underground metro constructions in such regions. Here are some examples from Chennai, where underground metro construction very close to the historical monuments can lead to disturbances in the foundation soil and the foundations of these structures, causing structural damage and non-structural damage. And these need to be monitored over a period of time. Of course, we're talking of a few years that that the historical construction is exposed to this sort of a disturbance. And probably at the end of the construction, the disturbance ceases to exist, but is definitely one of the hazards that we need to consider. So this multi-hazard scenario is a scenario within which we need to work. While our concern is mainly structural damage, we also have to pay attention to damage which might not be of structural nature, but may affect elements of artistic and architectural value. In that case, even low levels of the hazard can actually cause distress. You don't need a level of hazard to cause structural damage, but even before that, you can have non-structural damage. And this is typically encountered in buildings with valuable paintings or valuable architectural elements, which are non-structural and can be affected even before the structure can get affected. So this also needs to be kept in mind. Within the context of the Sustainable Development Goals 2030, we all are aware that cultural heritage has a very important role to play towards progress of the civilization. And it is in order to achieve sustainable cities and communities, which is the Sustainable Development Goal 11, it is essential that we protect and safeguard cultural and natural heritage, and that's the SDG number 11. This very nicely ties up with the objectives of the Sendai Framework for Disaster Risk Reduction 2015 to 2030, where it is essential that cities need to take steps to mitigate any effects of disasters, including aspects such as climate change, and therefore ensuring risk reduction in cultural heritage is an essential part of Sustainable Development Goal number 11. Well, now we need to focus on specifically the emergency response in built heritage, for which we need to understand in which part of the disaster management cycle are we really engaging. Generally, once an event occurs, there is an immediate period after the occurrence of the event, which is called the response period. That's the immediate response period, the emergency response period. And our focus is in this part of the disaster management cycle. However, we cannot dissociate ourselves from the rest of the cycle. So an event occurs, and in the immediate period after the occurrence of the calamity, we need to do safety evaluation and undertake short-term countermeasures. You might have to temporarily stabilize the structure, to even go in and inspect the structure, or salvage valuable items from the structure, or to even carry out further surveys and carry out rehabilitation. You need short-term temporary stabilization in such structures. So that's what is the activity in the immediate period after the occurrence of the event. But that then moves on into the recovery phase, where further detailed assessments are required, and one has to start doing quantitative assessment and rehabilitation of the structure, and you prepare the structure to be in a situation where it can face its function like before, but is also prepared for an event in the future. And that is where we are, again, we need to identify where we are within the cycle at that stage. So once you get into the recovery stage and go towards the mitigation stage, you are trying to ensure that the structure is now less vulnerable to a future event. You are at that stage almost out of the emergency response and reconstruction phase and enter the other phase, which is called the peacetime phase or the capacity building phase. In this phase, the primary objective of disaster management is to ensure that all other structures which were not affected in the previous event are assessed, and it is ensured that these structures are capable of resisting the natural disaster or whatever disaster has occurred. Capacity building exercises, training exercises have to be carried out. Structures might have to be retrofitted, and all these are the peacetime activities which will ensure that the impact of the disaster is lesser in case there is the event occurring after a few years. So you understand that this is a cyclic process, and we are always marching forward, and we really need to invest. After we invest in emergency response and reconstruction, we must invest in preparing for the next event.